Hi, a very good morning. In the previous sessions, we have completed the following concepts: exception handling, advanced exception handling, and list interface and array list. Now, in the next session, we are going to cover the following concept, which is stacks in Java. Stacks are very important, and let us get into what exactly stacks are. Before we dive into how do we use stacks, or else let's say we'll have a quick representation of what stack is. So now stack is a class which is available in java.utility package, okay, in standard edition 8. You can call the stack class, and a stack can take custom elements in it. The elements you can define as per your choice. The stack is extended using a vector class, so which means it inherits all the properties of vector also, and there are a few more methods which we will discuss. What is a stack? The stack class represents a last in first out stack of objects. Okay, it extends class vector with 5 operations that allow a vector to be treated as a stack. So in Java, basically we are using a vector. The vector is treated as a stack. Okay, the vector has some 5 operations, and we will understand what these 5 operations are. Now, what are the common operations of stack? The usual push and the pop operations are available. Push means you're going to enter an element into a stack, and pop means you're going to extract the element out of the stack. Okay, as well as what do we have is we have a peek method to get the top item on the stack. Okay, followed by a method to test whether the stack is empty, and a method to search the stack for an item and discover how far it is from the top. So these are the 5 methods which are available in the stack: push, pop, peek, whether it is empty or not, and search within the stack. Okay, cool. I hope this is clear to you.
Yes.
Now, when the stack is initialized or when it is created, it contains no items by default. Okay, so we are going to push the elements in it. We are going to perform the operations like searching within the stack, picking the stack, and then popping the elements out of the stack and checking whether the stack is empty or not. A more complete and consistent set of last in first out stack operations is provided by deque interface and its implementations, which should be used in preference to this class. So what do we get from this? There is a class known as deque, which we should use when it comes to stack, when we are implementing stacks in Java. So the documentation itself prefers that instead of using the stack class, which has been inherited from the vectors, it is always a good idea that you can use the deque class. Okay, we will understand both of these and what are the differences. Okay, now how it is implemented? It is implemented in this way. You're going to initialize a new ArrayDeque. You're going to define the type of the element which you want to hold within the stack, and then you are going to store it into a variable. Okay, now what all does it has? There are a few vectors which is inherited from the vector class. One is capacity increment, the number of elements data, and then there is some some fields which are inherited from the abstract list, which is the mod count. So we are going to understand how we can use it. What you can do is you can initialize the stack using the stack constructor by calling the new stack, and then you can execute these 5 methods. Whether the stack is empty, you looks at the object at the top of the stack without removing it from the stack. Then you can pop the element out of the stack. You can push the element out onto the top of the stack, and then you can search, and it returns the first based position where an object is on the stack. So suppose you have 2 elements within the stack which is same. So when you search, you're going to get the first based position, which means whoever is on the top, you're going to get that information in return. Apart from that, there are a lot of other methods also available in it, which includes add, add all, add element, capacity, clear, clone, contains. So you do have a huge range of methods which you can implement over the stack class other than these common 5 methods. Okay. Followed by, there are various other methods which have been inherited from the object class, which feeds like finalize, get class, notify, notify all. You have some methods inherited from the collection class, which is parallel, stream, and streams. Okay. So what do we do? So you can create an empty stack. Then what do we have is, we have this push item. In this, what you can do is you can push an item onto the top of the stack. It has the exactly same effect. You can also call the method add element, okay, within the stack. Add element is inherited from the vector class. Okay. Now what it returns,
Okay.
it will return you an item argument. So these are the methods which you can read about and you can implement. So what are we going to do? We are going to deep dive into the code. So let us just start our Eclipse code. And we are going to implement the following methods. Okay. I'll be using my Eclipse workspace. And we are going to implement a new project. And this is going to be the stack project. Now within the stack, what am I going to do? I'm going to create a class, my stack, and I'm going to get my public stub, and we're going to get started with the code. So what are we going to do? Initially, we are going to use the stack class, and what you can do is you can use both ways. You can construct using new stack. Okay, that's a constructor with which you can actually initialize. Let's say we're going to call a new stack. Once you call new stack, you have to import it from java.util package. Okay, otherwise you won't be able to access the stack. In case if you want to define what kind of element you want to put in, you can actually define that. Let's say I want to put an integer.
Okay.
Okay. The type of the elements which you want to put into the stack. So we can call, this is my stack, integer stack is equal to new stack integer. Okay.
Okay.
Now, what next we have to do? We can also define the type elements here if we need, but actually it is sufficient if you define at the right hand side itself. Okay, won't be a problem.
Okay.
Now, what do we have is, once we got the stack, okay, we have to check whether the stack is empty or not. So I'm going to check system.out.println is stack empty. So we are going to call this method integer stack dot empty. Here's a method which returns you a Boolean response. I'm going to run the cell, save all, run the cell. So you're going to get is stack empty. You're going to get true. Okay, so you can quickly check back the responses, the true and the false. This is the first method implementation. Then what we are going to do? Let's say we are going to push an item into the stack. So I'll get integer stack dot push. I want to push, let's say 10 within that. Okay. Then I'm going to check system.out.println, and I'm going to check get the top element of the stack. So I'm going to call integer stack, and I'm going to get the peak method executed. So when I run it, we're going to get that you have got the stack empty initially, then you pushed 10, and now if you want to get the top element, you can see that it is 10 in queue. Okay. Now again, I'm going to push another element, which is going to be 20. Let's say I'm going to put one more, which is going to be 20. And if I run it, Now you can see it's going to be 20 at the top. So which means it is the last in, first out structure. Okay. Now, what are you going to do? You're going to search the element. So in order to do that, we're going to get system.out.println is stack contains 20. So we're going to get the integer stack.search, and I'm going to search 10. So we're going to run it. Once I run, you can see that I've got a response, which is a number, and it gives me the position at which the element is identified so that I can extract that element out. Okay.
Okay.
It returns me the position on the stack. If I get 20 and if I run it, you can see that you're going to get it is the first position. So the topmost position is the first based position, and the first most element which has been inserted into the stack will eventually get the last position. Okay, is that clear?
Okay. Yes.
So we got that. Finally, I'm going to pop the element system.out.println. So I'm going to, I'm going to pop the element integer stack dot pop. So at pop, we're going to get an element extracted. And finally, I'm going to get system.out.println. And I'm going to get, sorry. Yeah, okay. I'm going to get the peak element. Integer stack dot top element of the pop. So I'm going to run this. Now you can see that we got the top element as 10. So I think we got all the 5 operations done: 1, 2, 3, 4, and the push and pop. Now, so there are similar methods which you can implement. Now we'll get into the second implementations, stacks using the deques. Stack using deque. And I'm going to get my stub. Now, what is stack using deque? We'll get to the next method. So there's an interface deque which you can also implement, and you can modify your code. Okay. So with the interface, what you can do is the type of elements held in this collection. So you can create a stack which extends vector. Instead of that, you can interface the deques also. Okay. Now, deque is an interface, but to use it, there are a couple of classes which are available over here which you can use, and it includes ArrayDeque, concurrent linked deque, and linked blocking deque. Okay, these are the following deques available which you can also use. Now, this is the interface deque which extends the queue class. Okay, now what is it? Let us have a quick look. A linear collection that supports element insertion and removal at both the ends. So queue or deque is a double queue. So double queue means you can remove it from the top as well as you can remove it from the end. Name deque is short for double-ended queue and is usually pronounced as deque. Okay, so we generally call it as deque, but the actual pronunciation is deque. So most deque implementations place no fixed limits on the number of elements they may contain. But this interface supports capacity restricted deques as well as those with no fixed size limit. This interface defines methods to access the elements at both ends of the deque. Methods are provided to insert, remove, and examine the element. Okay. Each of these
Okay.
methods exists in two forms. One throws an exception if the operation fails. The other returns a special value, either null or false, depending on the type of operation we are using. The latter form of the insert operation is designed specifically for use with capacity restricted DEC. In most implementations, insert operations cannot fail. The 12 methods which are described in the DEC are summarized as follows. What are these 12 methods? So you can insert the element in the following ways. You can add first, you can offer first, you can add last, you can offer last. Okay. So these are the two methods. You can throw an exception, or else you can get a special value like null, okay, or false once you insert the element at the first. There are other methods, removing the element at the head and removing the element at the tail. So there is remove first and poll first, remove last, poll last. Okay, both of these methods
Okay.
work in a similar way. Okay, just that the only value is the return statement. So here it's going to throw an exception if you are adding first and somehow it didn't add it, but it's always better to use the offer first because it will give you true or false. Okay, so instead of handling the
Okay.
exception, you can just have to check whether it's true or false. Got it?
Okay. Yes.
Now, the interface extends the queue interface. When a DEC is used as a queue, first in, first out behavior results. Elements are added at the end of the DEC and removed from the beginning. The methods inherited from the queue interface are precisely equivalent to DEC methods as indicated in the following table. So these are the methods which are available in queue and the dequeue. Okay, the queue and the DEC. Now you can add the element, you can add the last element, because when you add in a queue, it will automatically be added at the end of the queue. Okay. Similarly, in the
Okay.
DEC, since it's a doubly ended queue, so you have to call the method add last, followed by when you have to insert an element. In queue, we have an offer. Here, we have an offer last. Okay. Remove, remove first. Poll, poll first. Element, get first. Peak, peak first. Okay. So this is the difference between the queue interface implementations and the DEC. Okay. DEC can also be used as a last in first out stacks. This interface should be used in preference to the legacy stack class. So instead of using the stack, it's always better to use DECs as a stack. Okay. When a DEC is used as a stack, elements are pushed and popped from the beginning of the DEC. Stack methods are precisely equivalent to DEC methods as indicated. So here in the stack you had push, in the DEC we
Yes.
have add first. In the stack we had pop, we have the remove first. In the stack we had peak, here it is peak first. Got it? So the utility of DEC is that you can perform operations from both the ends of the data. And if you want to use it like a stack, you can use it like a stack. If you want to use it like a regular queue, you can use it like a queue. So DEC is always a better data structure instead of using stacks and queues individually. Got it?
Okay.
Note that the peak method works equally well when a DEC is used as a queue or a stack. Okay. In either case, elements are drawn from the beginning of the DEC. Now, so this is something which is very, very important, which you can implement. So what are we going to do? Let us just get to stack using DEC. So in order to use the DEC, since it's an interface, so we cannot use it directly. We have to get into ArrayDeque. Okay. All known implementing classes. So these are the classes which implements DEC. Okay. Now, when it comes to the DEC, how are you going to use it? You're going to use the class ArrayDeque with an element inside it. Okay. And then you will be able to apply the following methods on it. The benefit of ArrayDeque is it is a resizable array implementation of the DEC interface. ArrayDeques have no capacity restrictions. They grow as necessary to support usage. They are not thread safe. Thread safe means they are not synchronized. You have to make it thread safe explicitly, okay? So that you can
Okay.
get the data structure synchronized, so that if there are multiple threads accessing the same data structure, they should be synced, okay? In the absence of the external synchronization, they do not support concurrent access by multiple threads. Null elements are prohibited. This class is likely to be faster than stack when used as a stack and faster than linked list when used as a queue. Okay, so it's always better to use ArrayDeque instead of using linked list individually, or the queues individually, or the stacks individually. Okay.
Okay.
Most ArrayDeque operations run in amortized constant time, which means it's big O of one complexity. Okay. Amortized constant means big O of n complexity, sorry. Depending on the n number of elements in it, eventually the time of the operations will increase linearly. Okay.
Yes.
Exceptions include remove first occurrence, remove last occurrence, contains, iterator, iterator.remove, and the bulk operations, all of which run in linear time. So we got to see that. Now what we will do, we will get into the constructor. So how are we going to use it? Let's use it. So I'm going to call new ArrayDeque. Okay. You can define what are you going to use. I'm going to use strings here this time. I need to import it from java.util. I've got that imported. I have defined ArrayDeque. My deck. Okay. Now, so you can define it with the number of elements, how many elements you want to initialize. You can define it by default. It has a capacity to hold 16 elements because it's a 16-bit character. You can hold 16-bit. Sorry. Initially, you can hold 16 elements only in it. Okay. But if you want to have more number of capacity during initialization, you can define the number of elements. Also, you have an ArrayDeque where you can define the type of element with which you want to create your ArrayDeques. Okay. Now these are the methods which we can do. So what am I going to do? Let's say I'm going to call my deck and I want to add an element. So let's say I want to add Devanshu. Okay. So when I add Devanshu, what I want to do, I want to get the last element or get the first element or the last element, since it's only the first element added into the queue. Okay. So I'll get both system.out.println first element. So I'm going to get my deck dot get last. Similarly, sorry, get first. Okay. Similarly, I want to get the last one also. Last element. And I'm going to call it as get last. So now once we run it, you're going to get the first element and the last element. Both are Devanshu. Now I want to change the first element. So I am adding my deque dot add first. Okay. So I've called this method add first, and I'm going to add Bhavesh. So now this time Bhavesh will be added at the first position. So when I run it, you can see that the first element becomes Bhavesh and the last element becomes Devanshu. Okay. Got it? So we got add Add first. You can also, now let's say I want to add something at the last. My DQ dot add last, let's say new person. I'll add a new person at the last of the queue, let's say. Okay. So when I run it, so now both my first and last has been changed. And Devanshu, which I added at the first, now it has become an element at the center of the string. Okay. Then what you have is, you already know that you can quickly clone it, you can clear it, but I would like to check whether it contains. So my deck dot contains, let's say I'm going to check to contain Bhavesh, let's say, and I'm going to have a system.out.println, system.out.println. My TQE that contains Bhavesh. So I'm going to print that. Contains Bhavesh. We will get true or false. Okay. So the deck contains Bhavesh. We got it true. Okay. Then you have contains, you have already checked. You have a descending iterator. Okay. So it returns an iterator over the elements in the deque in reverse sequential order. Now, what could be an iterator? Let's have a look. So iterator is something with which you can iterate all the elements within the deck. Okay. So what are we going to do? We're going to call myDeque dot descending iterator. Okay. Now what this descending iterator would do, it will give you an iterator which will iterate over each element, okay, in the queue. So we can do something like this. For, let's say, I will take it as string name in myDeque dot descending iterator. If I call it that way, okay, it can only iterate over an array or an instance of java.lang.iterate. Okay, we'll do one thing. We'll use myDeque dot descending iterator. I'm going to save that into an iterator of string. My iterator importing iterator from java.util and my iterator dot. See, so what do we have is, we can call it in a way where we can use for each remaining, we can equals, we can has next. Okay, so what we can do is, we can call it with a while, let's say, while my iterator dot has next. Okay, so it's going to give me that list. I'm going to get my iterator dot get iterator dot next, and I'm going to print that out. System dot out dot print line my iterator dot next. It's going to give me the strings Okay, so that's how I'm going to print it. Let's have a look. So it gave me that I have iterated it in the descending order, and I've got all my elements have been extracted in the reverse order. New person, Devanshu and Bhavish. Okay, is that clear?
Okay. Yes.
I'll just print it in a way, system.out.println, iterating all elements in descending order. Okay, I believe you got it. So I'm going to run it, and I've got a message iterating all the elements in the descending order. So now I think you are also clear that how you can use the iterator. So with the while loop, has next will always give you an element one by one until and unless it is empty. So you don't need to implement a for each loop in a way. You can just call while. By the time iterator has the next element, you can print all those elements out, and you can perform any of the operations you want to perform on the iterator.
Okay.
I think you got it. Similarly, you can return all the elements through an iterator also in the ascending order. Okay. Now, what offer does, insert the specified element at the end of the deck, and offer first inserts at the top. Now, what I want to do, currently Bhavesh is at the top. So what I want,
Yes.
I just want to enter one more person. Okay. So I'm going to say my deck dot offer first. Okay. And let's say I'm going to add something like Salman, let's say. I'm going to save and I'm going to run. Now, once I run, now you can see that Salman become the first element. Okay. I added it at the top. No, I think the first element is Bhavesh. Last element
Yes.
is person. I should have got insert the specified element at the
And
front of this deck. Dot offer first.
yes, it's in the front only, I think.
Sorry.
I think it's in the front or not.
It should be at the front, right?
I think it's in front of Bhavesh only.
Inserts the specified element at the front of this deck. At the end of this deck. At the end of this deck. Okay. Not a problem. Let's see one more thing. Let's add one more. My deck dot offer. So I'm going to add Shahrukh, let's say. Okay. I got it. Why does that happen? I'll just put it here. Okay. It was just a print mistake. Because I was printing the first and last element first, and then I was getting all of the other items printed. Okay, so what I'll do,
Okay.
I have added the offer first and offer last. So initially it was Bhavesh, but this time
Yes.
it will be Salman at the top and Shahrukh at the last.
Okay.
Okay, so you have Salman at the first, Shahrukh at the last, and similarly the results. Got it? Since I got both of these statements printed after these, that's why we got that confusion. Okay, so I think you're clear.
Yes.
Rest of the elements you will be able to implement accordingly. All the remove first, get the first occurrence, get the size of the element. Okay, so
Okay.
you have to implement all of these functions, and since you already know that it works in an amortized constant, which means the number of elements it has, it's going to be of big O of n complexity. Okay, big O of n,
Okay.
big O notations will also understand at the end of the course, because I think those topics are also mentioned in the curriculum.
Yes.
So I believe this is clear. Now you understand stacks, how you can implement stack, and how you can implement stack using DQ, and why do we prefer DQs? Because they are faster with respect to linked list as well as the stacks.
Okay.
Okay.